Welcome back, folks. Still playing with this real simple BJT circuit. We want to find one more way to push this BJT into cutoff. Okay, so I have the original circuit up again. Let's take a look at that. And we changed RB, right? We choked off the flow of current here so that there was no drop across RC. And that meant that VC was 5 volts. So we want to kind of play the same game as we did before when we were pushing it into saturation. I can change the voltage across here by changing the current, and I did that by altering this resistor. Or I can change the voltage across here by altering the resistance, and that's what we're going to do here. So if I want a smaller drop across this resistance, we have to lower this resistor. Okay, so let's make it, I'm just picking an arbitrary number here, let's make it 5 ohms. Okay, make that one 5 ohms. That's going to change our VC. Okay, and it's over here. We got to change that to 5 ohms. All right, we go do some analysis. At least these videos are short, right? I'm going for short. I know you're home. I know this is not the way we want to be learning right now, but here we are. Okay, let's see. The 86K stayed the same. Oops. Just delete a parenthesis. 86K, and the 150 became 5 ohms. We run that, and we find that we get 4.95. So it's not quite 5, but we're kind of playing like, well, it's close to 5. It's very close to 5, and we can see that this is now approximately 5 volts. All right, so we run into the same problem as we did last time, where if we say what's VBE and it's 0.7, we might say that that looks like it's forward. Okay, when in, well, in this case it kind of is. Again, this table can get you in trouble. Okay, VBE is forward. VBC is equal to 0.7 minus essentially 5. Okay, so we get negative 4.3, and we would say that this is reversed. So again, we might look at this and say it's active, but if we're really close to 5, what's the functional difference? And there really isn't. There's really no room for that voltage to go any higher. Okay, not much room to go any higher. So we might say, what's VCE? And VCE in this case is 5 volts. And I think we would have a more meaningful conclusion if we look at VCE and we say, hey, this thing's in cutoff. Okay, so this is kind of why I prefer to look at VCE. I think it gives us a better intuitive sense of what's going on with this transistor. It can become an open, and when it's an open, it's going to be 5 volts. It can become a short, and when it's a short, it's going to be around 0 volts, or it can be somewhere in between. Okay, like we saw in the active region, we had 3.5 volts in between. So I'm trying to help you build an intuitive sense of how these things are working. I hope I've done that a little bit with these circuits, but my goal is to have you comfortable analyzing any circuit with BJT. So we have to start to build out some more complicated circuits. We'll start with some common ones, and then I'll throw in some ones that are just off the wall crazy, but you can do it if you can write the nodal equations. All right, stay tuned and good luck, folks.